Hello guys, how are you? Welcome to GeoMind. In this video, we will start the Permian period. So this video will be the part of geological timescale series that I have been doing, and I have already finished the Precambrian history of Earth and also all the eras of all the periods of Paleozoic era except the Permian period. Okay, so after finishing this Permian video series, our Paleozoic era will be complete. So this will be the part first, and if you want to check out, I will provide the link at the end of the video, and you can check the videos of different periods later. Okay, so this video will be in the part first and part second, two parts, and hopefully we will finish the Permian period in the two videos. So first of all, I would like to describe this thumbnail that I have put on my video. So this creature is a classic example of Permian diversification of reptiles, and this is known as Dimetrodon. Okay, very classic example of Permian period. So we will talk about this creature later in the video. Okay. So also, if you like this video, please like, share, and subscribe. Thank you. So as usual, our questions and answers. So first question is, the snowball Earth happened during which period? And you have to answer out of these four the correct answer in the comment box. Also in the question 2, the ammonites went extinct during which period? Okay, so please answer the questions, and I will give the answer in the second part of the Permian period. So let's start. First of all, we will look at the geological time scale and see where the Permian sits. So as you know, here is Permian, and it comes under the Paleozoic era, and which itself comes under the Phanerozoic eon. So I've already made videos on Archean and Proterozoic history, also on the Cambrian, Ordovician, Silurian, Devonian, and Carboniferous periods. Okay, and I have discussed thoroughly all the important events that happened during these periods. So as you can see, Permian spans from 299 to 251 million years. Okay, and it is divided into three series. Okay, early, middle, and late, and all have their respective names. So let's move on to more detailed chart of the Permian period. So here is the more detailed chart. As you can see, sorry, here Phanerozoic eon is not written. Okay, so the eon is Phanerozoic eon, era is Paleozoic era, Permian period, then three series. Okay, the lower series is Cisuralian, then Guadalupian, and Lopingian. Then all these three series are respectively divided into different stages. Okay, so you need not to remember all the stages. Okay, you can generally see that Permian is divided into three series. Now the GSSP, and by the way, all I have discussed all these, the difference between Eonothum, Eon, Erathum, Era, okay, system period in the previous videos. I've also described the GSSP, okay, discussed the GSSP, that what is GSSP. So the lower GSSP of the Permian period is Assalian. Assalian stage is marked by the conodont. Okay, so its name is very hard to pronounce. You just have to remember that the lower stage is marked by the conodont. Okay, the conodont is the GSSP, and the region is Ural Mountains. Okay, Adralash in Ural Mountains. Okay, so most of the stages in the Permian period is marked by the conodont. Okay, so conodont is very extremely important index fossils. Okay, and they are used in various exploration of petroleum especially, and correlation of strata. So I've also talked about the conodont in the previous videos. Okay, what is its importance? Okay, so this is all about the geological time scale of Permian period. So let's talk about the some introduction, that what is Permian period. And so Permian period in geological time scale is the last period of Paleozoic era. Okay, it's the last period and began roughly around 299 million years at the end of Carboniferous and ended at the 252 million years. Okay, so Permian period, as in previous videos I have discussed, is name from the Russian region of Perm, where rock deposited during this time are particularly well developed. So at the beginning of the period, glaciation was widespread. So in previous videos, I have said that the lower part of the Gondwana, okay, was sitting roughly at the South Pole. So glaciation was there at the end of Carboniferous period. Okay, so latitudinal climate belts were strongly developed, and the Permian period is known for its warm and arid climate. Okay, and by the end of the period, as you know, the Permian Triassic extinction is the largest extinction in the geological history of Earth, and they caused a crisis in Permian marine and terrestrial life. So temperatures were high, as we will see in the later part of the video when we will discuss the paleoclimate of Permian period. So this dramatic climate shift may have been partially triggered by the assembly of smaller continents into the supercontinent of Pangaea. So as you know, Pangaea was complete during the Permian time. Okay, so as this huge landmass was completed, it has its own repercussions. So most of the Earth's land area was incorporated into Pangaea. Okay, as Gondwana land fused uh, to Euro-America, and also Siberia and Kazakhstan were fused. Okay, so this was a very huge landmass, and we will see later, okay, what Earth looked like during the Permian period. And ocean was called Panthalassa. So Panthalassa was very huge ocean. Terrestrial plants diversified, okay, during Permian period. Insects evolved, but their size was very less as compared to the Carboniferous period, because oxygen levels were low during the Permian period as compared to the Carboniferous. Okay, and the reptiles diversified, and they give rise to the, you could say, the early mammals, okay, in the Mesozoic era. And most important factor is the Permian is known for this mass extinction in the Earth's history, the largest mass extinction. Okay, so this mass extinction was so severe that only 10% of the species were present after the Permian survival. So let's talk about some paleogeography. So this is the late Permian times. The Earth looked like this. So you can see this is a huge landmass known as Pangaea supercontinent, or the last supercontinent of the Earth. And these are the Central Pangean Mountains, or the Appalachian orogeny that I have discussed in the Carboniferous period. Okay, so there was huge mountains here. Okay, some were here, Ural Mountains, when the Siberian Kazakhstan fused with the Pangaea. Okay, Gondwana was sitting in the southern hemisphere, while the Northern America was in the northern hemisphere. Okay, India was part of the Gondwana and was closer to the South Pole. And here is the Tethyan Ocean, and this O-shaped ocean is known as Paleotethyan Ocean. Okay, now talking about the paleogeography, the distribution of land was something like this. Okay, so as you know, in the Permian times, in the whole Pangaea was complete. Okay, Alleghenian orogeny was complete. Okay, Hercynian orogeny was complete, and in the later part, okay, in the middle Permian, Angara, or also known as the Siberian Craton, fused uh, fused with the Pangaea and created the Ural Mountains. Okay, now talking about the paleoclimate. So paleoclimate, the temperature was 16 degrees Celsius. Okay, a little bit warm compared to today's. Atmospheric oxygen was 23%. Okay, so this was less compared to the Carboniferous period. In Carboniferous period, the oxygen was almost 35%. Okay, so very huge drop in the oxygen levels. The formation of Pangea led to dry and arid climate. So obviously, if there will be a huge landmass, okay, so the climate will be dry because, as you know, the land heats faster, okay, and it cools faster, so it has its own repercussions. So there will be desertification because of the mountains in between, okay, and the climate of the land will be arid and dry. Okay, so as it's written here, newly created high mountain ranges strongly affected the local and regional climate. Extensive glaciation in the early Permian stages persisted from the Carboniferous period. So when I'm talking about the arid and warm climate, it doesn't mean that the Permian period throughout had the arid or warm climate. So as you know, in the Carboniferous period, the glaciation was there in the southern hemisphere. Okay, so in the early Permian, the glaciation was still there. Okay, it persisted from the Carboniferous period, but in the middle Permian, the glaciation became very low. Okay, so in middle Permian, the climate was warm and moist, but in the late Permian, it was hot and dry. Okay, so you have to remember this. So desertification started because of the huge landmass, and volcanism strongly influenced the Permian climate at the end of the Permian. So as you know, when we'll talk about the Permian extinction, the main cause was the volcanism in the Siberian era. Okay, Siberian region. Okay, Siberian region, and Siberian flood basalt erupted about 250 million years. So that is end of the Permian, and erupted lava for almost 6 lakh years. So that was a very huge time. Okay, and it altered the Permian atmosphere. Now this is the paleoclimatic map of the Permian times. As you know, this yellow or brown region represent the hot desert, hot type of climate, okay, or steppe cold or arid climate, okay. So arid climate can both be hot and cold region, okay. But the most of the land was not moist. So you can see here arid and dry, and boreal or northern type of climate was present in the polar regions. It was less compared to the arid and dry climate. Okay. Now, so talking about the life. So first we have to describe this chart. So what it is that we have described this chart in the previous video also. So fish evolved to tetrapods. Okay, tetrapods evolved to amphibians and amniotes. We have talked about the amniotes. Amniotes were reptiles that laid eggs and had hard shells. Okay, then amniotes evolved to synapsids and diapsids. Okay, diapsids then evolved to archosaurs and lepidosaurs. Okay, so archosaurs were then evolved to dinosaurs. Okay, and from dinosaurs evolved birds. Okay, so crocodile is also a archosaurs. So archosaurs came in the Permian times. Same as synapsids, these came in the Permian times. Okay, and from these synapsids, mammals evolved like humans. Okay, all the mammals, placental mammals, you can say, and mammal-like reptiles were there in the Permian times, and we will talk about them later. So, what is the difference between synapsids and diapsids? So, synapsids, like modern mammals, have just one hole behind their eye socket. Okay, so Dimetrodon, which I have talked in the thumbnail, was a synapsid. Okay, it was a mammal, although it looked like the dinosaur, it was a mammal actually. Okay, and diapsids have two holes behind their eye sockets. So dinosaurs, crocodiles, okay, birds have two holes behind their eyes. So that's it for today's video, and in next video we will talk about the marine and terrestrial life. Okay, some evolutionary history of mammals. And then we will talk about different animals that were present there. Okay, and also the Permian extinction. Okay, the most important part. So that's it for today's video. I hope you liked it. Thank you. Please share and subscribe.